Okay, so to pick up where we left off, we just went through the three trig functions from the perspective of angle A. So what we're going to do now is do the three trig functions from angle B. All right, so we can kind of fit all this on the screen. All right, so the first one I'm going to do is the sine of angle B. So the sine from angle B. All right, the sine from any angle is always going to be the opposite over the hypotenuse. So from angle B, the opposite side is 12, and the hypotenuse is 13. So in a little bit, we're going to grab the calculator, and we're going to type this in, and then we will be able to figure out what angle B is using the side measurements. All right, so now let's try the cosine of angle B. So the cosine of any angle is always the adjacent over hypotenuse. So from angle B, the adjacent side is 5, and the reason why I know the adjacent side is 5 is because the hypotenuse is the 13. So adjacent over hypotenuse would give me 5/13. And then again, we would go to the calculator, we type this in using the cosine function, and it will tell us, the calculator will tell us what the value of angle B is. So then we do the tangent from angle B. So the tangent from angle B, the tangent from any angle is opposite over adjacent. So from angle B, the opposite side is 12, the adjacent side is 5. And then again, we could put this into the calculator using the tangent function, and the calculator will tell us what the angle measurement is. All right, so here's something I want to point out, and you might have noticed a little bit, maybe, possibly, with the color coding. Here, I think I should turn on some light. There we go. What you should notice is that the cosine from angle A is the same as the the sine of angle B. So the cosine of angle A and the sine of angle B are the same. Similarly, the sine of angle A is the same as the cosine of angle B. So those two are the same. And then between these two, what you should notice is that the tangent of A is the reciprocal to the tangent of B. Now, if you think about it, this will make perfect sense, because if we go back to our first page, the adjacent side for angle A is the opposite side for angle B, and the opposite side for angle A is the adjacent side for angle B. So those things should hopefully make sense. All right, now you might be asking why we're not doing sine, cosine, tangent from angle C. Well, we know what angle C is. It's 90 degrees. So there's no reason for us to find the sine, cosine, or tangent from angle C, because we already know that angle C is 90 degrees. All right, so let's try another one. One over there is 1. I'm going to say that is 3, and this side is 7, which didn't show up at all. So let's try again. So we'll say this side is 3, and that side is 7. Okay, so on this problem, just like the last one, I only have 2 of the sides. So first off, what might have to happen is that I cannot use sine or cosine because I do not know the value of the hypotenuse. So I can't use the functions that would need to know the hypotenuse. And the 2 functions that need to know the hypotenuse are sine and cosine. However, since I do know the 2 other sides, I can use Pythagorean Theorem to get the side C. So if we do this, we know that A and B are the 3 and the 7. I'm easy. So if we use Pythagorean Theorem, we could say that 3 squared plus 7 squared would equal C squared. So 9 plus 49 equals C squared. So we add that up, we get 58 equals C squared. So C is going to be the square root of 58. And it just so happens that one can't be simplified. So the square root of 58, instead of making that into a decimal, I'm going to leave this one as a square root because it would be more accurate to leave it than to estimate it. Alright, so now I have the 3 sides, so I can go through and write the trig functions for angle A and angle B. So, slide over a little bit. So first, I'm going to go through and do the sine from angle A. Alright, so from angle A, the sine is the opposite over the hypotenuse. So from angle A, the sine would be 3 over the square root of 58. Now, if we were doing any other problem, we would not leave a square root in the denominator, but at this point, we would just go to the calculator, type this information in, and the calculator will tell us the measurement for angle A. All right, let's do the cosine from angle A. So from angle A, the cosine is going to be the adjacent over the hypotenuse. So that would be 7 over the square root of 58. All right, last one is tangent. So we'll do the tangent from angle A. So the tangent function is always going to be the opposite over the adjacent. So from angle A, the opposite side is 3, the adjacent side is 7, so this would be 3/7. So now we're going to go through and do the 3 trig functions from perspective of angle B. So first up, we'll do the sine from angle B. Oops, there's Maisie again. So the sine from angle B. All right, so the sine function is always the opposite over the hypotenuse. So from angle B, the opposite is 7, the hypotenuse is the square root of 58. So that would give us 7 over square root of 58, and then we would go to the calculator, type it in, and the calculator will tell us the size of angle B. All right, now looking from the cosine of B, so the cosine of any function is always the adjacent side over a hypotenuse. So from angle B, this is the adjacent side, and I know that because the square root of 58 is the hypotenuse. And then the last one is the tangent from angle B. So from angle B, the tangent is going to always be the opposite side over the adjacent side. So from angle B, 7 is the opposite, and 3 is the adjacent. And I know this is the adjacent side because that one is the hypotenuse. So again, just like on the last problem, the cosine of A is the same as the sine of B. The sine of A is the same as the cosine of B. And the tangent is just the reciprocal. All right. So next up, we're going to work on just identifying which trig function we can use. So for our next example, so this is example 3. And I didn't bring my flare pens home, so I'm using these old Crayola markers. Alright, so I'm going to draw this triangle. And I'm going to label this A, B, and C again. Alright, and for this problem, I'm going to tell you that this side is 9 and this side is 13. And the directions in this case would be to use the given information to write a trig function. Okay, so there's more than one possible answer. So for this first one, we are just going to go ahead and fill in all of them, both of them that we could do, and then we'll work on which one is the best one as we go further on. All right, so if I know these two sides, looking at this triangle, I know that this side right over here is the hypotenuse. So the two sides that I know must be the opposite and the adjacent. But remember, this is the opposite of A but adjacent to B, and this is the opposite of B but adjacent to A. So if we think about what trig function would relate the opposite and adjacent sides together, then I know for this problem I have to use the tangent, because the tangent from the angle measurement is always going to equal the opposite over the adjacent. So that means that if I was at angle A, from angle A, the opposite is 9 and the adjacent is 13. So I could use that one. Or I could use the tangent from angle B, and from angle B, the opposite is 13 and the adjacent side is 9. So we could use that one. So those are two possible answers right there that would solve this triangle for me. All right, next up. Oops, move up a little more. All right, so let's say, for example 4, I'm going to go back to normal here, but this time I'm just going to call it X, Y, Z, just to be different. And for this problem, I'm going to tell you that this side is 6, and I'm going to tell you that this side is 13. All right, so what we need to do here is write a possible trig function that we could use to solve this triangle. So we know the hypotenuse, so we know that this one right here is the hypotenuse. So that tells me that we could use the sine function or the cosine function. So if we were using the sine function, it's going to be opposite over hypotenuse. If we're using cosine, it's going to be adjacent over hypotenuse. And it doesn't matter, so we'll do both. So the opposite side is across from the z. So the sine from angle Z would be opposite over adjacent. And this one would be adjacent if we were at angle X. So then that tells me that the cosine from angle X would be 6 over 13. So those are two possible trig ratios that we could come up with using this triangle.